Good day, engineers. So ngayon, ang i-discuss natin is yung sample problem for our Mohr's circle. So simulan natin yung discussion on sample problem number 1. For our sample problem number 1, so from the elements shown, determine the following. First, the maximum and minimum principal stresses, and for letter B, the stresses on plane AB. So ito yung element natin. It consists of vertical forces na or vertical normal forces na 120 kilopascal and horizontal normal forces na 250 kilopascal and shear stresses of 95 kilopascals. Then, pinapahanap niya yung angle or stresses on plane AB which has an angle of 37 degrees which is counterclockwise from our vertical plane or the right vertical plane. So, this is figure SP1-1. So, for our given, we have a given of the soil element which is shown in figure SP1-1. The required values or the required properties are the maximum principal stress, the minimum principal stress, the normal stress at plane AB, and the shear stress at plane AB. Then the equation to be used will be the Mohr's circle procedures or steps and its concepts. So to solve this problem, so meron tayo nung given na element. So una nating step is to determine the direction of all the forces in this element. So mag-start tayo dun sa mga normal stresses. Yung normal stresses natin consists of the vertical stress or the vertical normal stress which is 120 kilopascal and yung horizontal normal stress na 250 kilopascal. Ngayon, yung 120 kilopascal na nag-a-act sa top and sa bottom horizontal plane are both towards the element. Therefore, these two will be in compression. While yung 250 kilopascal na nag-a-act dun sa left and right side, so left and right side na vertical plane is towards din dun sa element natin. Therefore, these two will be in compression as well. So since in compression sila, so that will be positive forces or positive stresses. So we proceed now to the shear stresses. So para dun sa shear stresses natin, meron tayong nag-a-act sa top plane and dun sa bottom plane. So para ma-determine natin yung direction nila, let's put a reference point inside the element. So this one, kapag ginamit natin yun as a reference point for the moment or the rotation, the element on the top plane or the stress on the top plane will rotate counterclockwise. Then, the stress at the bottom plane will also rotate counterclockwise. So that means the stresses on that planes will be positive. Then for the case of the stresses on the vertical planes, so ito yun, kapag ginamit natin yung same reference point or the same dot inside the element, so yung nasa left side na stress will cause a rotation na clockwise, while yung stress on the right side ng element will also cause a clockwise rotation. Now, from that, we can say that shear stresses are negative since it rotates clockwise. So, we can now prepare our ordered pairs, which are 120/95 for the stresses on the horizontal planes. So, ito yun. Since counterclockwise yung shear stress niya and in compression yung normal stress, then we have 250 -95 for the stresses on the vertical planes. So, since yung rotation ng shear stresses niya is clockwise, so that is negative. And compression siya, so that will be positive. So, plotting this one on our Mohr's circle, we have yung 120/95 na sigma y and tau xy is nasa quadrant 1 since lesser si 120 kaysa kay 250. Then, since ang partner ni 250 is -95, we can plot it on quadrant 4. Then, we draw the Mohr's circle using that 2 points, or we draw a circle using that 2 points. Then, connecting those 2 points, you will create the diameter of the circle. So, from that diameter, we can also have, or it will intersect a center of the circle, which is ito. So, we have to determine its coordinate. Automatically, the ordinate of the center of the circle will be 0. Kasi nandito siya sa point na to. So, we just have to determine the value of sigma c, which is this one. So, to determine sigma c, we have to use the midpoint formula, which will be sigma c is equal to sigma x plus sigma y over 2. So, sigma x is 250 and sigma y is 120. So, that means that will be 250 kilopascal plus 120 over 2. Then, the sigma c now will be equivalent to 185 kilopascal. Yan ngayon yung coordinate ng center ng circle natin. So, yung coordinate will be 185, 0. Ito ngayon magiging coordinate ng circle or center ng circle natin at point C. Now, after getting the coordinate of the center of the circle, we are now ready to get the radius of the circle. Pwede natin kunin yung radius ng circle from this part, or pwede rin natin kunin yung radius na yon from this part. So, it will be your choice kung saan pwedeng kunin or kung saan nyo gustong kunin yung radius of our circle. So, for the radius of our circle, we have the radius as x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. So, that will be the square root of the answer. So, for our radius, ang ginamit nating point will be yung lower side, ito. So, ginawa nating x sub 2 si 250. Si point C pala, which is the center of the circle. So, that will be yung 185, ima-minus sa 250. So, i-squared natin yon. Then, ang partner niya, -95 and 0 yung axis doon or yung x doon. So, that is 0 yung ordinate o yung y coordinate, which is 0 minus -95. So, quantity squared. So, our radius from that analysis will be the radius 5 square root of 530 kilopascal. Now, that will be the radius or base radius for our circle. Since meron na tayong radius nung Mohr's circle natin at meron na din tayong coordinate nung center ng circle natin, we are now ready to determine other stresses in our Mohr's circle using the properties such as the center and the radius of the circle. So now we are on the next step. We would like to determine the maximum and the minimum principal stresses. So, magsimula tayo dun sa minimum principal stress. So, as we can see, this is the point or yung pinakamababang point ng circle for our sigma. So, that will be the minimum principal stress. And it is at the left of the center. So, ibig sabihin, wala dito sa center, papupuntahin natin doon sa point na yun para maging minimum principal stress. So, to do that one, we have to subtract the value of sigma c to the value of our radius. So, for our minimum principal stress, we have sigma 3 is equal to sigma c minus r. So that will be 185 minus 5 square root of 530 kilopascal. So we will have a sigma 3, which is the required, and that is equivalent to 69.8914. Then, the next one will be to determine the maximum principal stress. So ang point where it is maximum on the sigma or yung circle natin maximum on the sigma axis is ito. So, it is at the right of our center. So, to determine the value of the maximum principal stress, we need to add sigma c dun sa radius natin since that is to the right. So, to determine the value of the maximum principal stress, we have sigma 1 is equal to sigma c plus r. Then sigma 1 is equal to 185 plus 5 square root of 530. Calculating that one, it will be a value equivalent to sigma 1 is equal to 300.1086 kilopascal. So now we have the maximum principal stress of our given point or from our given. So as an additional, from the properties given, we would also like to determine the location of the pole. So yung pole natin, malolocate natin yan kung aalamin natin yung kung saan tumatama yung mga forces dun sa element natin. So, alam natin na yung 120/95, tumatama yan on our horizontal plane or top and bottom horizontal plane. So, kapag ito yung element na given kanina, tumatama yan sa taas tsaka sa baba, then yung shear stresses niyan, dun din tumatama. So, ibig sabihin, para malocate natin yung pole, we would draw a line which is horizontal from 120/95 up to a certain point in the circle. So, eto yun. Ngayon, on the other way around, yung 250-95, tumatama yan on our vertical planes. So, pwedeng sa left side, pwedeng sa right side. So, to determine the location of the pole, we would draw a line from 250-95, which is vertical. So, kung saan siya mag-intersect dun sa circle natin, that will be the pole. So, meron ding intersection yung dalawang kinreate nating line, the horizontal and the vertical plane. So, that means the pole is this one. So, to determine that coordinate, so, the coordinate of our pole now will be, since ito, yung pole natin, tumama yung pole on the sigma side sa 250. So, the coordinate of the pole or the abscissa of the pole is 250. Now, its ordinate will be the value, ito siya. So, tumama siya sa positive 95. So, that will be a positive 95. So, our pole now will be 250, 95. Then, after getting the pole, isa pang importanteng property nung circle natin will be the value beta. Si beta kasi, pwede natin gamitin as reference kapag kukunin na natin yung stress on plane AB nung element natin. So, to determine beta, let's extract a triangle which is ABC. So, makakabuo kasi tayo ng triangle na to. So, let's extract the triangle ABC. So, triangle ABC will be consisting of a height na 95 kilopascal, which is yung shear stress na nandito. Then, it will also have an R, yung radius ng circle natin, and a value on the horizontal line segment AC, which is x sub 1. Now, to determine the value of beta, we can get it from our sine function, which is opposite divided by the hypotenuse. So, sine function will be sine beta is equal to 95 over r. So, ang hinahanap natin is beta. So, that will be beta is equal to the inverse sine of 95 over 5 square root ng 530 since our radius is 5 square root ng 530. So, calculating that one, we will have 55.6197 degrees. So, meron na tayong beta ngayon and it is ready now for use para malaman natin yung plane AB. Alternatively, since we are given 2 points in the Mohr's circle or in our circle, we can use the equation of the circle, which is the center radius form, to determine the radius and the center or the coordinate of the center of the circle. So, ito ginagawa kapag yung given natin is kahit anong point dun sa Mohr's circle. Basta it is around the perimeter of our circle. So, we'll use x minus h squared plus y minus k squared is equal to r squared. Where yung c natin has a coordinate of sigma c0. So, based lang kasi to dun sa figure natin na automatically magsi-zero yung value ng center ng circle natin. So, pag hindi 0 yon, there should be a given ordinate for our center of the circle. So, kasi we need 2 equations, 2 unknowns. So, kaya 2 equations kasi we are unknown with sigma c, tapos unknown din yung radius ng circle natin. So, para mapunan yung 2 equations, 2 unknowns, so, magkakaroon tayo ng 2 equations. So, the first equation will be x sub 1 minus h squared plus y sub 1 minus k squared is equal to r squared. And our second equation will be x sub 2 minus h squared plus y sub 2 minus k squared is equal to r squared. So, any of the points in our circle can be x sub 1, y sub 1, and it can also be x sub 2, y sub 2. Since given tayo ng 2 points, which is 120.95 and 250 negative 95, pwede natin yun gamiting dalawa. So, equate natin yung dalawang equation, yung equation 1 and 2. So, since r squared naman silang dalawa, so pinag-equate na natin silang dalawa. So, we may have x sub 1 minus h squared plus y sub 1 minus 0. Since 0 yung ordinate ng center, squared is equal to x sub 2 minus h squared plus y sub 2 minus 0 squared. So, i-simplify natin tong x sub 1 minus h squared at x sub 2 minus h squared. So, we will now have an x sub 1 squared minus 2x sub 1h plus h squared. Tapos yung y sub 1 is magiging squared din, and we have x sub 2 squared minus 2x sub 2h plus h squared plus y sub 2 squared. So, arranging the term, iiwanan natin itong mga 2x sub 1 on the left side. The rest will be transposed to the right side. So, we will have 2x sub 2 minus 2x sub 1h, x sub 2 squared minus x sub 1 squared, and y sub 2 squared minus y sub 1 squared. As you can see, magka-cancel yung h squared kasi pag ito, inilipat natin dun sa kabila, it will become negative h squared, may positive h squared dito. So, they will cancel out. So, now we will have this term. So, ilabas natin yung h. So, we will have h times the quantity 2x sub 2 minus 2x sub 1 is equal to x sub 2 squared minus x sub 1 squared plus y sub 2 squared minus y sub 1 squared. So, dividing both sides by 2x sub 2 minus 2x sub 1 squared, we will now have the equation for the abscissa of the center as x sub 2 squared minus x sub 1 squared plus y sub 2 squared minus y sub 1 squared over 2x sub 2 minus 2x sub 1. So, ibig sabihin, ito pwede natin gamitin kapag ang ordinate ng center ng circle is 0 at kapag given tayo ng 2 points sa ating Mohr's circle. So, gagamitin natin yung formula na yan. We will have, so ginawa natin na x sub 2 si 250, y sub 2 si negative 95, at x sub 1 si 120, at y sub 1 si 95. So, we will now have 250 squared minus 120 squared plus negative 95 squared minus 95 squared divided by 2 times 250 minus 2 times 120. So, kanina, ang center or abscissa natin ng center is 185. So, this value will also be 185 kapag ginamit natin itong formula na to in getting the abscissa of the center. So, substituting this one to any of the two equations above. So, pag sinubstitute natin, so kunin natin yung y sub 1 tsaka x sub 1 or yung equation number 1. So, substitute natin yung 120 minus 185, 95 para makuha yung radius. So, para lang din tong distance formula. So, that will be 120 minus 185 squared plus 95 minus 0 squared. So, that will be a value of the radius 5 square root ng 530 kilopascal. So, this is an alternative for our equations na pwede nating gamitin to determine the radius and the center of the ordinate or the center of the circle. So now, since kompleto na tayo dun sa mga properties ng Mohr's circle natin, may radius na tayo, meron na tayong coordinate ng center, and meron na tayong beta angle, alam na din natin yung location ng pole. So, pwede na nating kunin yung pinapahanap na stresses sa plane AB. So, as we can see, on this element, nagro-rotate yung plane AB from the right vertical plane which is counterclockwise sa kanya. So, that is a value 37 degrees. So, ang coordinate or ang forces na nandun sa right vertical plane is yung 250 tsaka negative 95. So, sa radius niya natin, kukunin yung pag-ikot sa Mohr's circle. So, kung kukunin natin yung Mohr's circle, ito siya. So, kung ito yung radius na nakadugtong or ito yung radius na dugtong yung center tsaka yung 250 negative 95. Ito ngayon yung iikutin natin ng twice ng 37 degrees, which is, ang twice niya is 74. So, ang ikot nito sa element is counterclockwise. So, dapat sa Mohr's circle, counterclockwise din siya. So, mula dito, ikutin natin counterclockwise. So, ayan. So, as you can see, we will have a 74 degrees dito. Tapos, dito siya hihinto. Itong line na to. So, ibig sabihin, nandito sa point na to, yung hinahanap nating stresses. So, para mahanap muna yung stresses na yun, since sabi ko nga, yung beta angle dyan will play a vital role in getting the angle nung hinahanap natin. So, as you can see in this figure, tinake natin itong value na to nung angle as an alpha. So, angle alpha now plus beta will be equal to 74. And since alpha na yung hahanapin natin para makuha yung stresses dito sa point P, so that means we have alpha is now equal to 74 degrees minus beta. Then, our beta na nakuha natin kanina is 55.6197. So, that will be alpha is equal to 74 minus 55.6197. So, our alpha now is 18.3803. So, we can now have this value of alpha. So, now, para makuha naman natin yung stresses na hinahanap natin on plane AB, we can get triangle CDE, which is ito yung na-form na triangle nung nag-ikot tayo ng 74 degrees. So, extracting that triangle from our Mohr's circle, so, ito yung CDE. So, ang unang-una nating pwedeng makuha dyan is yung tau. Remember, given na tayo ng R, and kakukuha lang natin ng value ng alpha. So, to get the value of tau, we need the sine function. So, that will be sine of tau or sine of alpha is equal to tau over R. Since tau yung hinahanap natin, we will have an equation. Tau is equal to R sine alpha. So, substituting the values, we will have tau is equal to 5, square root ng 530, sine ng 18.3803. So, our value ng tau na required is 36.2964 kilopascal. Then, after getting the value of tau, pwede nating kunin ngayon yung x sub 2 using the Pythagorean theorem or by using the cosine function. So in this example, we got it from the Pythagorean theorem, which is x sub 2 is equal to r squared minus tau squared. So substituting the value of the radius and our tau, we have square root ng 5, square root ng 530 squared minus 36.2964 squared. So, calculating that one, we will have the value of x sub 2. So, this must be, so this is a typo error since that will just be x sub 2. So, that is x sub 2 is equal to 109.2363 kilopascal. So, hindi pa ito yung hinahanap natin na normal stress dun sa plane AB. Kasi, as you can see, balik tayo dun sa Mohr's circle, ito pa lang siya. That is just the length of segment CE. Ngayon, para makuha natin yung hinahanap na sigma or normal stress, kailangan nating i-add yung since ito yung sigma c which is the abscissa of the center, i-add natin yung nakuha nating x sub 2 which is the length of the segment CE para makuha natin yung total value na. So, ang goal natin is hanapin si sigma. So, that will be an addition of sigma c and x sub 2. So, to add those two values, we have sigma is equal to sigma c plus x sub 2. So, 185, which is the center or the abscissa of our center, plus 109.2363. Then we calculate, we now have 294.2363 kilopascal. Now, na-determine na natin yung shear stress on plane AB and lahat ng required properties dun sa Mohr's circle natin. So, yung answer dun sa mga required natin will be the maximum principal stress, sigma 1 is 300.1086 kilopascal. Yung minimum principal stress natin is sigma 3 which is 69.8914 kilopascal. And yung normal stress natin at plane AB is a sigma which is 294.2363 kilopascal. And our shear stress at plane AB will be a value tau which is equal to 36.2964 kilopascal. So that will be all for this presentation of sample problem number 1. We will have another sample problem on our next video. So thank you for watching and hope you have learned something. Again, this is Engineer Rodolfo and don't forget to subscribe to Butch TV.